5?
No, we said 3.
3. Absolute value of x plus 5? Okay, I'm on the wrong sheet. Hold on.
Yeah, hold on.
This one? Alright, so the first thing I need to do is find that vertex, right? And to find that vertex, I need to take that 3 out from the front. So I'm going to make this 3 times x minus, and if I take it out of 4, it doesn't go in evenly, so I just make it a fraction. 4/3. Yes? The only reason I do that is so that I can find the vertex. So what is the vertex here? 4/3, 0. All right, so I'm going to go 4/3, which is a little past 1, right here. And then I'm going to pick 2 to the right and 2 to the left. So 2 to the left, maybe I pick 1 and 0. And 2 to the right, maybe I pick 2 and 3. And I'm just going to use my calculator to find these points, right? I'm going to go into the table, and I'm going to find those points. So y equals, yeah, sure. Absolute value, 3x minus 4. Table, 1, 0, 2, 3. I got 1, 4, 2, 5. One, 4, 2, 2, 4, 5. Something like that. Domain. That's exactly right. Range. There you go. That's the X part. So are you talking about the domain or the range? The domain. So whenever I get here, I don't stop. I keep going. There's a point there. So I go from left to right. There's no place it can't be. All these absolute values will be negative infinity to infinity for the domain. Yeah. That's still a 0 for the X part of the vertex. Like if it's this, the vertex is still 0, 0. You wouldn't have to worry about taking it out of anything if that's what you're asking. Well, you'd have to look to see if that falls in your restriction. Well, it does, but which one are you looking at? If it was piecewise. Well, so it would depend on what your restriction was on the end. So if it said 2x when x is bigger than 1, well, that wouldn't matter because 0 is not bigger than 1. But if it said less than 1, then it would matter because 0 is less than 1. So I'd have to look to see if it fits this restriction as to if I'm going to graph it. If it fits it, I graph it. If it doesn't, I don't. No, this was number 3. No, that was just a random example she was asking about. She was just asking about if it was a piecewise, what happened. So which one? Give me a problem. Like 5. So number 5. Negative absolute value of x plus 3 if x is less than or equal to negative 2, and 4x plus 1 if x is greater than negative 2. First things first, I'm going to look at the first equation. So here, what is my vertex? 0, 3. Is 0 less than negative 2? No, right? No, so I don't have to worry about this because it doesn't fit in this requirement. So now I just do everything like I've been doing. I'm going to plug in. If I plug in -2, what do I get back out? 1. Somebody said 1. Is it open or closed? Closed. Right? And now my easy points, I'm less than -2, -3, and what do you get? 0. There's that piece. Okay. If I kept going, right, because that vertex was supposed to be here, it would do something like this, but I don't need that dash part because that's not in my restriction. Yes. No. Right, right. The restriction, because this is saying negative, this is saying at -2. That's my barrier there. That's my wall. Yeah. So if this were over here, then I would cut it off here and I would need all of this. Right. It could be. Yes. Yeah, I will. All right, let me finish this one and then we'll move to the next one. All right. The next part is just linear, so if I plug in -2, I get -7. -2, -7 with an open dot. Then I plug in one bigger than -2, -1, you get -3. Goes like this, so it looks this way. Domain? There you go. Negative infinity to infinity. Nothing stopping it left to right. How about the range? Negative infinity, positive infinity. It goes down forever. It goes up forever. There's no holes or breaks yet. What do you mean? You could. Number 6. F of x equals, and I've got 3 equations this time, -1 if x is less than or equal to -6. Negative x minus 4 if x is between -6 and 0. And absolute value of 2x minus 5 if x is greater than 0. On what? Yeah. All right. Again, everything's just a plug-in until I get to this last one, and then I got to think about some things, right? -6, -1. No matter what I plug in for x, I'm getting -1 back out. It doesn't matter. So -6, -1. If you understand what it looks like, no, you don't. But if you want to do an easy one, -7, it's -1 again. You know that it goes off forever like this. Okay. Next one, again, I'm plugging in. If I plug in -6, I get 2. Oh, -6, 2. If I plug in 0, I get -4. Closed dot on that one. So I've got this piece, this line segment here, yes? All right, now the hard part. Now the absolute value one. So the first thing, because I have a number in front, I have to take that out. I have x minus 5 over 2. What is my vertex there? Is 5 over 2 bigger than 0? Yes, so I need it, okay? So I'm going to go ahead and plot it. 1, 2, 3 at 2.5, right here. There's my vertex, yes? Now here's what I'm going to do. I'm going to plug in the restriction still, because that's my cutoff point. That's where my absolute value is cutting off. So if I plug in 0, I get, well, positive 5, right? Because it's absolute value. So 1, 2, 3, 4, 5. Oops, that's an open dot. I'm going to go ahead and connect these two, but that's not the whole story, right? Because it's an absolute value. So I've got to pick up something where it's flipping over and going the other way. So I need a number on this side of the vertex. So maybe I pick 3. 2 times 3 is 6, minus 5 is 1. So 5, 3, 1, sorry. This is not an inequality, this is just a piecewise. So no. The only time you do that is when you have inequalities. How about domain here? Range is a little funky. So it goes down forever. It's got a low point, right? What's the lowest the graph ever goes? -4. Bracket or parenthesis. And then I go up. This one goes up until this point, but this one's got some graphs. So what do I go up until? Infinity. You see, I hit a roadblock here, but this graph picks it up. Then I hit a roadblock here, but it picks up on this side, and it's always going up. There's never a y value that doesn't correspond. Does that answer your questions about those? What else on your homework? You have a question? What you got? 10? All right, I'm going to run through these quickly since you want all 4 of these. Number 7, f of x is greater than or equal to absolute value of x plus 2. I'm going to run the same. I'm going to graph it the same way I do any other inequality. The only difference is solid, dashed, and shading. Okay, what's my vertex here? 0, 2. 2 on one side, 2 on the other. So 1 and 2. That's exactly what I would do. If I plug in -1, I get 3. If I plug in -2, I get 4. Same thing here, I get 3 and 4. So -1, 3, and -2, 4. Same on this side. This one is solid because of that line. And greater than means I shade up. Number 8. F of x is less than negative absolute value x minus 4. Where is my vertex? 4, 0. I need 2 above, 2 below. 3 and 2. There you go. If I plug in 3, I get -1. 2, I get -2. That negative sits out front there. All right, 1, 2, 3, 4, 0. 3, -1. 2, -2. Same on this side. This one is going to be dashed because there's no line under the inequality sign. I'm less than shades down. 9's probably the hardest one on there. -1/4, -3. So I do have to take something out here, and because the 1's not divisible, I have to just write it as a fraction. And remember, I'm only doing this when I find the vertex past there. I don't even have to worry about it anymore. So the vertex here is -1/4, -3. What about there? It's the opposite sign here. Your vertex is always opposite sign inside. I would do 0 and -1, and then I would probably do 1 and 2. 0 would be -2. -1 would be 0. Is that right? 1 would be 2, and 2 would be -6. So 0, -2, -1, 0, 1. Is that right? One, 2, and 2, 6. That's right. Okay. It must just be because my numbering is off. And 2, 6. And that's what they should be. Should I shade up or down? Down, so I'm going to go outside of this. Last one, number 10. This one's a little bit easier. Why? There you go. Look at you. You're on fire up here. 6 is divisible by 3, so I can take it out evenly. I can't forget that negative this out front. So what's my vertex? -2, 1, right? 2 on either side, so -1, 0, and then -3, -4. At -1, I get -2. At 0, I get, there you go. Should be the same here. -2, 1, -1, -2, 0, 5. Solid or dashed? In or out? Up. Yeah. And they are 3 parent functions we have talked about extensively already. So first of all, what's a parent function? I hope you know that from Algebra 1.
The original function.
It's like an original function. It's like the most basic function that you can come up with for different types of graphs. So for instance, the ones we're going to look at, we're going to look at linear, quadratic, and absolute value. Okay. And we just spent a long time on the absolute value ones, right? So the equations for linear, it would just be f of x equals x, which if I graphed that, that's just a line that goes through 0, 0, 1, 1, and so on. It has a slope of 1. So that's what the linear parent graph looks like. If I'm going too fast through this, let me know, because I'm just kind of brushing the surface here with these. What do you think the parent graph for quadratic looks like? What's the equation look like? F of x equals just x squared. That's exactly right. And then you said it's a U. What do we call that? A parabola. The vertex sits at 0, 0. It has the points 1, 1 and -1, 1, and it curves this way. Yep, that's quadratic. And then absolute value is, of course, what we've been doing, and it has the exact same points that the quadratic has, but what's the difference in the graph here? It's a V instead of a U, right? Instead of curving and being smooth, it is a sharp, we call it a corner in calculus. So these graphs, we are going to be shifting and sliding and reflecting and stretching and shrinking and doing all kinds of stuff to come up with new graphs, but they're all based on the parent graphs. And we're going to focus on these three function families right now, just linear, quadratic, and absolute value. Everybody okay? All right. While I'm here, yes, I'll be here but not here. I'll actually be upstairs. I'll be doing some observations in the math department. I know, this is where but I won't be in here Thursday. Miss Corner. Everybody.
You know who's a really good
Right?
Oh yeah, I do do questions. Miss Phelps? Yeah, she is.
people like to hate on her? Yeah, literally people hated on her just because she was yellow a little bit. Okay, but when you don't like her, she was chilling all what? I didn't really. She taught so good. Her tests were easy and she taught so good. People didn't like her teaching methods because what she would do is she would teach us.
I want to get through this. This is just the intro lesson to it. Okay. Tell me quickly, domain and range on linear, what is it? Yep. Oh, for both domain and range, right? Huh? Yeah. Let me think what else you might need to know. Yes. How many zeros does it have? What do I mean when I say zero? Intercepts what? The x-axis. The x-axis. One. Will it ever have more than one? Could it? It's one line. There's no way I can move it to have more than one, right? But it's remaining linear. No, right? Only one. That's what zero means. Yes, yes. Zero always means x-intercept. You mean like a horizontal line? That's not. We're just talking about the parent right now too, though. But no, it's just not. Yeah. But all the linear family, we won't talk about horizontal line. We'll talk about one that has a slope, a defined slope.
So it's like the parent function is what it is, and then if it were like.
And then we'll start moving it. Yeah. How about the quadratic domain? That's right. What about the range? What is it? 0, right? Because this is the parent, so it sits on the origin. 0 to what? Infinity. Bracket or parentheses? Bracket. 1, 0 for this one. As I move it and transform it, I could have 2. In fact, I could have 0, 1, or 2 zeros. Right? Remember we talked about that? We could have, if I shift it, right, I could have 2 zeros. I could have no zeros. Right. 2 zeros. Up to 2 zeros. 0 to 2 zeros, yeah. How about absolute value? What's the domain? There you go. What's the range? 0 to infinity. In fact, all of this is the same as, this has 1, 0. It's the same as the quadratic. All right. Yep. Same as that. All right, here's what we're going to do. We're going to start with translations today. They're the easiest. Huh? So translations, now you got to rewind back to geometry. Okay? What is a translation? Well, I call them slides. Don't you say slides? Right. You just shoot. You can move left, right, up, down. You just move it, right? The shape, yeah. No, those rotations. You can't rotate it. You can't make it any bigger. It has to remain exactly the same, but you can slide it to the left or the right or up or down. Okay? So that's a translation. So we're going to talk about how to do this graphically as well as from the equation itself. And we're always starting from our parent graph. Okay? Parent graph, of course, bless you. From quadratics and absolute values, we start at 0, 0, 1, 1, that V or that U, and then the linear parent graph that goes through 0, 0 also. Okay? So if you look at your cheat sheet that I call it, the first 4 lines deal with translations. Okay, so we've got translations up, down, left, and right. And I'm going to show you how this works and what this means. All right, so let's look at the first. Let's look at to up. Not to the up, but up. When you want to move a function up, you simply add the number to the end of the equation. So this is f of x plus c. We'll take it up c. But what that's saying is just take that whole equation that's there and just add it on there. So in other words, if I had f of x equals x squared plus 7, this would be the parent graph. And the parent, remember, 0, 0, 1, 1, negative 1, 1. Here's the parent, right? This one would just take every single point, slide up. So I would take every y coordinate. If you look at the column that says change, it says take the xy that you started with, and then you see the little arrow where it points over. It goes like this. It says xy changes to x, stays the same, but every y you add that value to. So instead of 0, 0, it becomes 0, 7. Instead of 1, 1, well, x is going to stay the same, and I'm going to add 7 to y. So it would be 1, 8. And same thing here, negative 1, 1 would become negative 1, 8. Does that make sense? Okay, where did I lose you? So this, because it's hooked onto the end, this says move it up 7. Every point slides up 7, up 7, up 7. To move up 7, I'm changing the y coordinate, not the x coordinate. Does that make sense? Okay. I can do the same thing to go down. But as I move down, I'm subtracting from the end. So let's do even what's happening here. Down 2. So if I started, remember that parent 0, 0, 1, 1, negative 1, 1 looks like this. This is an absolute value, looks a little different. To slide down 2, I take this same graph, and each of these points goes down 2. So 1, 2, 1, 2, 1, 2. Notice the shape has not changed. It hasn't turned over. It hasn't done any of that. It just slid. That's it. Does that make sense? All right. Okay. that exciting? Uh, yes, yes. Because if I'm moving down, I'm subtracting from it. So instead of 1, 1, if I subtract 2 from here, I get 1, negative 1. That's how you use the little cheat sheet. Really, you'll use the little cheat sheet more whenever we get into the shrinks and stretches than you will now. But all right, ready for left, right? All right, left, right. This is the most confusing. This has to do with the x value. And what you will find with transformations is anything to do with x is always opposite. Remember how whenever we're in those parentheses or the absolute value, it's always opposite h, same k? Same kind of thing here, because anything with x is going to be opposite. So it's hard to remember, but we can do it. It also, these are hooked to the x. Anything left, right is out, and I'll show you why. That yes, yes. If you subtract from x, not the end of the equation, but it has to be hooked to the x. Any operation being done to x, these are generally in parentheses, and then that operation is outside, and I'll show you exactly what I'm talking about. Subtracted from x moves to the right, and added to x moves to the left. Let me show you. Notice how this is going to be different than this one, okay? Linear, because of the way it is, a shift left or right can be the same thing as a shift up or down, so it does work. You don't really have an operation to hold it in. Good question, man. All right, so here, do you see the difference in these two equations? This one is moving down 1. What's happening with this first one? It's moving right 1, okay? That's why I said opposite. It's inside the absolute value, okay? How does it work with quadratics? So x minus 1 squared as opposed to x squared minus 1. Does that make sense? Is everybody okay? I'm going to practice 2 different things with you, just one of each really quickly, then I'm going to set you loose. I bless you. And that is, if I give you a graph, you give me the equation. If I give you the equation, you give me the graph. Okay? And this is what you'll be doing on your homework, because tonight you will do 1 through 11. By the way, you can do these together too. You can go left, right, and up, down. Yeah. So if you remember how to do this from Algebra 1 and you want to jump straight on it, be my guest. Go ahead. First off, what's the parent function here? f of x equals absolute value. Tell me what transformations happen to get from the parent to where I am now. Right 1 and up 1. We all agree, right? What would your new equation be if you went right 1, up 1 from the parent graph? X minus 1, that's all in absolute value, plus 1. Does that make sense? Inside the absolute value is my left right, but it's opposite. So since I moved right 1, I'm going to subtract 1. And then up, down, 6 outside at the end of the equation. Yep. Yes, the baby vertex. It would have been plus. What's the vertex of this absolute value? 1, 1. Look, what do you notice? That's how we were graphing it before, right? We were pulling that HK out.
Good morning, Kim.
What's the parent function here? So, x squared, that's exactly right. What transformations are happening to the parent here? You see? So I've taken my regular parent, right? And remember with a quadratic, you start at the vertex with the parent and you just go over 1, up 1 for that first point. So here I start, if I take that initial parent vertex and I move it left 2 and up 3, here's my new vertex, and then just over 1, up 1, over 1, up 1. Here's my new graph. All right, normally I do